Hello class, welcome to our second lesson dealing with simple harmonic motion. This is the end of chapter 4 in section 5. We looked at a little bit of this the other day dealing with the S of t formula, mainly cosine formulas because it's the spring being compressed or expanded to start with and then let go. So I want to go through a few of those questions again and make sure we review some of those things to ensure you're ready for this week's homework and test. The first question gives you the equation. You just have to find all the pieces. Remember, A is the amplitude. That's always the starting position. So that's S of 0 is the starting position. So that's 0.25. That's why it's 0.25 for the amplitude. Omega, remember, is just the B value. So 2 pi over B equals the period. Notice they gave you the frequency of 52. You could use the frequency formula if you would like. I tend to switch it and just make it the period and then cross multiply. So 1 over 52 would equal 2 pi over omega, or the B value. And if you cross multiply, you get 104 pi, and that's the number that would go in front of t. That would be your equation for position of the harmonic motion in this question. The next one is the exact same idea. You'll notice that the initial position is negative, which means it's just being expanded or pulled down or expanded and then let go, as opposed to the last one, which was compressed. It says the period is 10, so you set 10 equal to 2 pi over w, or omega. Cross multiply and solve, you'll end up with pi over 5. That's the number that goes in front of the t value for that question. Remember, it's cosine because the initial position is not 0. This next question gives you initial position of 5, so that's the amplitude. The period is 1.5. I would say on questions like this, you don't want any decimals in your answer typically, so you want to make 1.5 probably 3 over 2. And then when you cross multiply and solve, you get 4 pi over 3. When you plug in 1, it says evaluate S of 1. Remember, your calculator has to be in radians in order to find that answer. You plug in 1 for time. You should get negative 2.5. Now, the second part of the question is the graph, or is the weight moving up or down? So it's like you let go. At that time, is it on its way back down or on its way back up? And the number itself doesn't tell you that. So the number just says it's below equilibrium, which means it's stretched out. But the important thing about this graph is it's a regular cosine graph because the initial position is positive. It makes the cosine graph and ends at the period of 1.5. That means halfway is 0.75. So for the first 0.75 seconds, the graph is going downward, or the spring is moving down. And at 0.75, it reaches its lowest point, and then it's moving on its way back up. So just because this number is negative does not affect the up and down aspect of the question. This is moving back up because in the graph, in the first half of it, it's moving downward, and in the second half, it's moving upward. This next question is one of the few situations that you'll see a sine graph. Almost every single other one was a cosine graph that we've dealt with because you're pulling the string down or condensing it upward and then letting go. For this question, anytime you're dealing with harmonic motion of something moving around a circle, that's going to be a sine equation because the initial position is on the origin or on the positive x-axis, which is the normal starting spot for tangent. So this is the one example that will have sine. All the rest will have cosine. And the key thing here is moving uniformly around a circle of radius 2. That's the position. So that's the amplitude. And then they say the angular speed is 4 radians per second. That's omega. So if you remember back to when we did linear and angular speed, omega was angular speed, and it's still angular speed here. And we don't even have to solve anything in order to find that because they're giving you angular speed. That's why these questions have omega in them and not just a b value. It means something specific in these cases, and that deals with angular speed. So to recap, almost every question is going to be a cosine question. This is the only scenario that wouldn't be. The initial position is the amplitude. Make sure you know if it's positive or negative. Probably the hardest question is this moving up or down question, just because it's a little bit different than what we're used to. And then your calculator has to be in degree mode, or excuse me, in radian mode, not degree mode, in order to solve these questions when you're trying to evaluate a specific location. Have a good day, everyone.